with the opportunity to answer questions and stuff. So if you have something that you wanted to ask about or see done or whatever, that's totally fine. We can knock a couple of those out, or one or none or whatever you guys want. Reese, right? Homework 5, number 5. Sure. Okay. So let's do that. So the first thing I'm going to observe is that because that's a degree 4 polynomial, I have 4 solutions. And then using my RRT list, I'm going to have the factors of 30 divided by the factors of 2. So my factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. So I have each of those over 1, and then I have each of those over 2. Now I'm not going to write 2 over 2 because that just reduces to 1 that's already on my list. And I'm not going to write 6 over 2 because that reduces to 3 that's already on my list. Nor 10 over 2 because that reduces to 5 that's already on my list. And I'm not going to write 30 over 2 because that reduces to 15 and it's already on the list. If you wanted to write those down, that's okay. That's not wrong. I'm just saving myself some pen strokes or whatever. Cool so far? Okay. Now it's time to go to the graph. So I'm going to go ahead and type in that polynomial, exactly as it's written. So 2x to the 4th plus 13x to the 3rd plus 11x squared minus 26x minus 30. I'm going to go ahead and set my window that I'm going to graph. I'll go from negative 30 to positive 30. I'm with the assumption that I'm going to have to zoom that in. And I'm going to reset my y's to my usual negative 3 to positive 3. Sure.
I don't get
when I'm setting my window? So what the window is doing is it's describing like what piece of graph paper basically it's going to put the graph on. So the x-min says how far left are we going to go. The x-max says how far right we're going to go. The y-min says how far down are we going to go. And the y-max says how far up we're going to go. So basically creates a rectangle that you're going to look at the graph in. So when I set mine, I use the RRT numbers to get my x-min and x-max. So the biggest and smallest number from the RRT is what I'm putting in for the x-min and x-max. And typically the y-min and y-max I'm just going to leave at like negative 3 and positive 3. I might change those if I can't see something well enough and I need to take a closer look and like zoom in on a little section. But that's basically what I'm doing. Does that help? Okay. So then I'm going to hit graph and take a look at what's going on. Now, as I suspected, most of the space on my graph isn't really used. It's blank, right? So I'm going to take another zoom in. I'm going to try to go from like here to here and just look at this little section of it where the x-intercepts are. So I'm going to guess that this spot over here is around negative 5. So I'm probably going to pick like negative 7 or something just to be on the safe side to make sure I capture that x-intercept. And this one looks like maybe positive 1, so I might pick positive 2 or 3 just to make sure I catch that on the other side. So maybe we'll go negative 7 to positive 3. I'm just kind of guesstimating there. And I'd want to overestimate rather than underestimate because I really want to make sure that I get those values. Okay, so I have here, this looks like negative 1, 2, 3, 4. That's negative 5. So I'm looking at the x-intercepts now in the graph, where the graph crosses the x-axis. Does that make sense, Emma? Are you sure? Okay. I see this one that looks like it's somewhere between 1 and 2. I guess to me that looks a little bit less than halfway, so maybe I'll call it 1.4. I'm just making an estimate, so it doesn't really matter. And then I have this spot here that looks like it's about 1.4, or negative 1.4, maybe negative 1.5. Okay with that? But if I go and I look here now at determining whether these are rational or irrational, well, negative 5 is on my list up above, right there. But 1.4 isn't. Now 1.5 is, because I have 3 over 2, but I'm pretty sure that's less than halfway over there. So that's probably irrational. It's not totally sure on that, but it's probably. Now, negative 1.5 is on my list. But again, I'm not totally sure on that because, I could be, if it was negative 1.6 or something, or negative 1.4, I wasn't totally sure. Those numbers aren't on my rational list. But more concerning here is I have 4 solutions. I see 3 x-intercepts. One of them is, I'm pretty sure, is irrational. The irrationals I know should be coming in pairs. It feels like there's one missing here that I just haven't seen. Any guess as to where you think that missing one might be hiding? I bet it's right here. I bet there's actually 2 going on there. That piece that looks like a bounce, I bet is actually 2 separate x-intercepts. So I'm going to go take a closer look at that area. That's happening between negative 2 and negative 1. So I'm going to reset my window to go from negative 2 to negative 1. And I'm going to take a big old fat zoom into that section and maybe go negative 0.1 to positive 0.1 on the y. So I want to see what's happening above that x-axis there, if there is indeed anything going on. So there's my new graph, and I see that what I thought maybe was initially a bounce, when I zoom in closer, I can see is actually 2 separate pieces. You guys see that? Now that was tricky to see that. It was not obvious that that was going to be the case. I really had to kind of think about what was going on and look at the number of x-intercepts I had and the irrational and rationalness of things. And really the fact that the irrationals come in pairs made a big difference there. So let's see. So it looks like I have also a negative, right? That's about halfway, so that piece is about negative 1.4. So that would be irrational. That would make that rational, and now I'm pretty sure that that's what's going on. So Reese, this was a tricky one, right? In sorting this out. Although I think everything would have gone okay as long as you made sure that you knew that, and that's what you started with, which is what I would do. I don't want to start with the decimals if I don't have to. I'd rather avoid those. Sometimes you can, sometimes you can't, but let's see what we got here. So we have 2, 13, 11, you know what? Let's do this. I don't need that calculator anymore. Absolutely, yes. Never have to ask. Just go ahead and do it. If you can't see it, I'm sure somebody else can't see. It's important that you see what's going on. The projector's pretty good, but it ain't that good. So let's go ahead and do the synthetic divisions here. So that worked. And now we have a choice here. We brought this down to a 4-term polynomial, right? With that synthetic division, you count, there's 4 numbers at the bottom, not counting the last number that's the remainder that's actually not part of the next polynomial. So we could try to exit to the factoring tree at this step and see how that goes. Or we could try doing another synthetic division with the negative 1.5 that we think is rational. Me personally, I would exit to try the factoring tree piece because I'm not positive that I have the rational and the irrational parts squared away there, because that was still a little bit fuzzy when we did it. So that's what I'm going to try. It turns out the negative 1.5 is going to work. I figure talking through it and doing it the way that I would do it maybe is the safer bet. So this has 4 terms. So when I look at my factoring tree, to do 4, I have to do grouping. So I'm going to make my 2 groups. Inside the first group, I can take out an x squared, leaving me with 2x plus 3. From the second group, I can take out a negative 2, leaving me with 2x plus 3. Since they both have a 2x plus 3 in them, I take that out, and I'm left with x squared minus 2. And can't forget that going all the way down. The 2x plus 3 I know can't factor anymore because it's linear. And the x squared minus 2 I can't factor anymore because the 2 isn't a perfect square. And obviously it's not a sum or difference of cubes since it's degree 2. So that's as far as I could get on that piece. This was a tricky one, Reese. You really had to pay careful attention on what was going on with your graph. To get that to work out for you. But I did that intentionally, right? I tried to give you some tricky ones in the homework where spending time looking at your graph and thinking about it made a big difference. Lily? Sure. So, were you able to do number 2 from homework 6? Because if you didn't do part 2, you can't do part 5. Or, you know, Lily?
Yeah.
Did you do 2?
No, okay, I messed that up.
Okay. So to do 5, we have to do 2. And that's okay. I just wanted to be clear on that these, 4, 5, and 6 depended on your answers from 1, 2, and 3. Okay. Was it due today?
Like due last Sunday.
No, it's for this. It's for this check. I think I gave it to you guys on Friday, but I said it wasn't going to be due until this homework check. And if you're ever unsure about that too, Emma, the Power School calendar I try to make sure is nice and accurate about when stuff is due. So if you go and look at the calendar for the class, you should see what's going on. Yeah, I know it sometimes gets confusing. I try not to have the different I have classes on A day and B day, and I try not to have a different amount of homework due at the homework check, depending on which class you're in. Okay. I just want to explain to you why sometimes you have homework due one week and not the next week or whatever. So Lily, this is degree 7, so it has 7 solutions. The rational solutions are just going to be plus or 1 and plus or minus 2. Again, they're the factors of the constant term divided by the factors of the leading coefficient. And then I'm going to go look at my graph. And this will spend most of our time is looking at this graph. We're really typing the graph into our calculator because I have to do it with my mouse and it goes so slow. Okay. So I got it typed in. Now I'm going to graph this. The window I'm going to use, I'm going to go actually a little bit bigger and smaller than +2 and -2. I'm going to do -3 to +3 because if there's a bend or bounce there at the end, I want to have a little bit extra so I can make sure I see that. And then I have to change my y's back to -3 and +3 because I changed those when we zoomed in on the last problem. So there's that. I'm going to go ahead and hit graph and take a look at what I see. Okay, so Lily, if I look at this piece I feel for sure about. That's, again, I'd estimate that to maybe be 1.4. And I see that's going straight through. And since 1.4 isn't on my RRT list, I know for surely that's irrational. Feel good about that? Now, the other section of my graph, I have this big long stretch where it looks like it's flat on the x-axis. That's awfully suspicious to me. I can't really pick out an individual x-intercept, so what am I going to do there? I'm going to zoom into that section and try to get a better look at what's going on in that part. So I'll go from like -2 to 0, and then I'll go maybe from -1 to +1. I don't really know for sure, but that's where I'm going to start. And if I have to do a second or third zoom, that's okay. In fact, I think I know I need to do a lot of zooming. I did this in the previous class. So here's what I did. And you see that it didn't really get much improvement, right? It's still just like spending most of the time on the x-axis. Well, that's a pooper scooper. So this is what I'm going to do. I'm going to cheat a little because I know that how far I have to zoom in to get a good picture because I did this already just a minute ago. So this is what I'm zooming into, which is wicked zoomed in, right? That's like a tiny little sliver, but it'll get me a pretty good picture. Now that makes a heck of a lot of difference there looking at that picture, right? So this piece is a straight. I'm going to estimate that to be about -1.4, which is good because that's my other irrational that's going to go with the, because I know those have to come in pairs. And then it looks like at -2 I have a bend, and that one's definitely rational because that's on my list. Does that feel okay there, Lily?
Yeah.
Okay. And you agree that that's a bend? Okay. Looks pretty textbook bendy. So I'm going to make my list of possible solution sets. I'm going to fill out that little table. Now the total is 7, and it's always got to be 7 because that's the number of solutions. I'm going to just pool 1.4 and -1.4 together as my irrationals. And those are going to, since they're straights, they're always just going to be 1 each, giving me 2 total. Feel okay so far?
Yeah.
Okay. Now the -2 is a bend. The bends occur an odd number of times, at least 3. So the minimum is 3. So 3 plus 2 is 5. I have to get to 7. So I know that the other 2 would be imaginary. Okay, there. But I could also be used an odd number of times more than 3. So I could do 5. 5 and 2 is 7. That leaves no room for imaginaries to get to 7. And that's all I could do, right? I can't get to 7 because I already have 2 accounted for, and that would give me too many. Does that feel okay so far? Yeah. Okay. So I'm going to start then doing my synthetic division with -2. I know I can do it at least 3 times. I'm going to keep an eye out for situations where maybe I can stop doing the synthetic division and do some other kind of factoring along the way, but it might not really be possible to do that. Also take note that I had to put a 0 in there because we had no x to the fourths. So that would have been an easy thing to forget, especially on a long polynomial like that. If you forgot the 0 there, no chance in getting the right answer, unfortunately. So let's do our synthetic divisions. What did I do? I made a mess out of this problem last time also when I did this. I can't believe I'm not doing better. Let's see, 7, 6, 5, 0, 3, 2, 1, 0. Okay. So 1, 5, 8, 0, -15, -19, -10, -2. Okay. And that's -2, 3, 6, that's 2. 2 times -2 is -4, -4. 8, 7, 14, -5, +10, that gives me 0, and that's didn't work. Did I write down the wrong thing from the graph? Is that -1 instead? Oh my crap. That's what it was. That's supposed to be a -1. That would do it. You ever feel like you're just being dumb? You're having a dumb day? Yeah, that's what it felt like there. That was a rookie move, Kulik. There we go. And if I look at that, I didn't get, basically what I'm looking for on these intermediates is, do I get like a 2-term, 3-term, or 4-term polynomial left? I definitely didn't, so I'm just going to go ahead and do another division. Because unless I get something fancy like that, there's not really anything I can do with it. Again, didn't get a 2, 3, or 4-term polynomial. So I did another one. And again, I didn't get a 2, 3, or 4-term polynomial. And I know that -1 might be used 5 times. It doesn't have to be 3 times. So I'm going to keep going and try doing some more divisions with -1 to see if I can keep, if that'll keep working. It did. That's awesome. I have a 4-term polynomial here that I could factor by grouping. But I'm going to just keep going because I know that I can use this 5 times. So okay with that. Now I'm going to stop because what I'm left with is a 2-term polynomial. That's a great situation. I have my 5x plus 1s. And then I have here constant x squared. that piece. So that's 2. That's my answer for 2. To do 5, we have this factored polynomial then equal to 0. So that allows me to set each factors equal to 0. So the x plus ones are easy. I just subtract 1 from both sides. So there's 5 solutions right there. Bingo, bango, bongo. The last piece is a quadratic. So I have to be a little bit more careful solving there. But I notice that quadratic has only x squareds. It doesn't have x's. So that's one I could solve directly. So I'm just going to add 2 to both sides. And then square root both sides. Remembering that when I square root both sides of an equation, I get a plus or minus. So I have 1, 2, 3, 4, 5, and then 1 for the positive and 1 for the negative makes 7 total solutions, which is what I was supposed to get. Just as an aside, if you type the square root of 2 in your calculator, that is about 1.41 yada yada yada. So that's when we saw the 1.4 and negative 1.4 on the graph, those were actually square root of 2 and negative square root 2. But that's the gist of that one. Does that help, Lily?
Yeah.
You're welcome. So again, probably the stumbling block on this was the calculator part and like getting the information you needed out of the graph to find those x-intercepts. Because sometimes they're just like, you got to do a little bit of zooming and playing around with it till you get a decent picture and can tell what's going on. And then you actually have to read your picture correctly, not write down the wrong number like I did, because that's a problem also. When you're the math teacher, you can recover from that because you'll notice real quick why it's not working. It's like, okay, I wrote it down right. Okay, the arithmetic's right. Okay, what's the issue? Maybe that I wrote down the wrong x-intercept. Let me go back and look at that. No, that was what it was. Anyways, should we stop here and let you guys start working on this stuff? Seems like that's a good amount of questions to do.